Okay, now let's talk a little bit about the top kill. And remember, the top kill is the procedure we're putting in place to pump heavy drilling mud down into the well to overcome the flow of the well and ultimately shut it off. So let's break it down into what are we going to have going on at the surface, what has been going on subsea, and then I'll actually show you an animation of what it looks like when it all comes together. So you've heard me mention a few times about the Q4000. This will be the command vessel for the operation of the top kill, and it's the vessel that actually has the ability to hold the drill pipe that goes from the surface down to the seafloor, and I'll show you that in a minute. As we're speaking, we're bringing in our primary kill vessel, which is the Haas Centerline. I believe it's either the largest or one of the largest supply vessels in the world. It will be our primary pumping vessel. It has the ability to pump 50 barrels a minute of the kill mud, and we'll have 30,000 barrels of mud on board. So that's the primary vessel. But we always want to have excess capacity. So we have a second vessel here known as the Blue Dolphin, which has equal amount of pumping capacity, even a little more, with another 11,000 barrels of mud on it. We'll have a standby vessel that can equally substitute for the Blue Dolphin in terms of pumping capacity. And then we have another vessel that has excess mud. What I want you to take away from this is we've put a lot of redundancy into the system to make sure we don't have any issues. Okay, so this is the surface. Now let's take a look at what we've been working on for the past week or so to install the equipment on the seafloor. I think people have seen this graphic before. So here's the well that is flowing. And what have we had to do since then to prepare to be able to pump this top kill? First of all, we had to take the yellow pod off, which we successfully did. We took it to surface, refurbished it, reconnected the cables, reinstalled it. That was all done with ROVs. And we've successfully been able to activate 2 isolation valves. So we believe we put the functionality of that pod back to work. Tomorrow, or shortly thereafter, we will actually go and do some diagnostic work, which I'll mention in a minute, and we'll further evaluate the ability of that pod to actuate all of the control valves we need to along the BOP. What we also had to do was go cut off the choke and kill lines, prepare connections so we could put these Coflex hoses to a manifold which we had installed on the seafloor over a week ago, and then finally connect these final Coflex hoses back to the drill pipe, back to the surface. That gives us a system where we have the pumping capacity at the surface. This is the connection point that gets us into the well, and then we'll have the ability to control the wells. Before we pump this top kill, while the top kill has been used all over the world, it's been successful many times, it's also not worked in other places. We want to do some further diagnostic work to help us understand what's really going on inside the BOP. That will give us a better idea exactly how to go after the top kill, and it will help us better understand how to do it to make this a successful process. Okay, now let me go to an animation of this. And to do that, what I'm going to do is I'm going to show you how we're going to pump mud from the Haas through the Q4000, down the drill pipe, into the well, and how it will ultimately flow to the bottom of the well and hopefully kill it. So let's watch that in animation. So here we are. From the pumping vessel, the Haas, the mud comes into the Q4000, goes down through the drill pipe to the equipment we've put on the seafloor. It ultimately goes in through the control valves into the BOP and starts fighting against the flow of the well. As it does that, the hydrostatic head of the heavier drill mud resists the flow, and ultimately when we pump enough mud, we will be able to overcome the flow of the well and completely bring it static. That is the plan. That is what we're working on to make happen. We will do everything in our power to make that successful, but as we've always talked about, we never rely on one option. So let's talk about what else we're doing. So I think everyone's aware we have the riser insertion tool, which we'll continue to optimize. We've also further refined those designs to make it more effective in capturing more of the oil and gas. And we have another riser insertion tool already on the seafloor that can be changed out when we think that's appropriate to do so. The next option we're looking at is what we call our LMRP cap. And this is something we've been working at for quite some period of time, but it's the diagnostic work we've done lately and the ability that we wanted to try the kill shot first that has brought this option to be the next option that we'll do if the top kill is not successful. So let me show you a little bit what we're talking about with the LMRP cap. Through the diagnostic work, we were able to figure out, and some really good engineering work, how we could actually go, cut the riser off, and create a flange that would be of sufficient flatness that we could actually seal off against it. If you remember from the previous cofferdam, we talked about the problems with hydrates. And how do we keep the seawater out? The riser insertion tool was effective in doing that. But we now believe we've created an option that will allow us to restrict the seawater entering in and creating hydrates and capture more of the flow coming from the well. So what we'll do is, once again, we'll use the Enterprise. We'll use the same riser and drill pipe configuration that we have with the riser insertion tool. But this lower marine riser package is what LMRP stands for, CAP, will be connected to the Enterprise, and then after the riser's cut off and the flange is prepared properly, it will come down, and there's actually a sealing grommet that would seal on top of that. It won't create a seal that would hold pressure, but it will create a seal that will avoid the seawater coming in and creating the hydrating problems. We'll also have the methanol line to avoid the hydrates forming as well. We believe by doing this, we will create an option that will capture more of the flow than we've been able to capture so far. Okay, so that's the LMRP cap option. Of course, we also have other options. I've talked to you previously about the option of we could take the LMRP off of the existing BOP and put a second BOP on top of it. Depending on pressures, that would allow us to either shut in the well or collect the flow of oil through a production system. That has its risks and challenges, but the team is continuing to progress that where that's a viable option. And as I mentioned previously, we're drilling 2 relief wells. One's currently at 10,100 feet and the other's at 8,600 feet. So let me conclude where I started. This is about people. This is about very dedicated people. This is about engineering, technical people, operations people. BP's brought in all their experts from all over the world. We brought in people from our competitors, from service companies. We have the best and brightest minds from the government. We're putting everything we can to solve this problem. We're absolutely committed. When the teams are working, they don't have to question when they want to order a part. They just do it. Money is not the issue. BP is 100% behind this. And I really appreciate their commitment. They're making a difference. The teamwork, the creativity, the technology, and the openness to ideas. We've had some 15,000 ideas come from the public. We've worked diligently to bring those ideas in, to meld those with what we're doing, to create the plan that I just talked about. It's really a tremendous effort. Thank you.